Hi everyone, very good evening and welcome back to Geeks for Geeks practice. Welcome back to another problem of the day discussion. So today we'll be discussing the problem that is power of numbers, which has been asked in a couple of companies like Walmart. So hi Rishit and hi everyone else as well. Guys, please give me a +1 in the chat if everything is working fine, and then I'll share my screen so that we can discuss the problem of the day for yesterday. Okay. So I am sharing my screen now. Let me know once it's visible. I think that the screen is visible. All right. Uh, okay. So I think that the screen is perfectly visible. All right. So yeah, basically this is the problem, power of numbers. So basically what will be given is, will be given a number n. Okay. So suppose that will be given a particular number n here. So n can be anything. Suppose that n is given as 21 here. Okay. And then we will be like, suppose that n is given as 12. Okay. So we will also be given the reverse number of it. Okay. So reverse number will be what? Reverse number of this 12 will be nothing but 21. So basically we have to find what? We have to find n to the power r. So basically you can say that you have to find what? You have to kind of find a to the power b. Is this part clear? So we have to do what? We have to find a to the power b, or you can say we have to find something like a to the a to the power b. That's pretty much clear to everyone, right, guys? What we have to do in this problem, you have to find a to the power b, because you have been given the number and you have been given its reverse also. Basically you have to find n to the power r. So in summary, you just have to find a to the power b. That is the normal concept. Now if you will find a to the power b, okay, so if suppose that you are finding a to the power b, so what does this means? This means that you have to multiply a b number of times. Okay, you have to multiply a how many times? B times you have to multiply it, correct? So similarly here also, like in this case, if you will see, so you have to multiply n into n into like r times, correct? So in this case you can run a loop. Correct, guys? What we can do is, if we'll talk about the very basic approach of doing the problem, so what we can do, we can simply run a loop and we can keep on multiplying in a particular answer variable. We can keep on multiplying a to the answer b number of times. Okay, so that is what we can do, and we can keep on taking the modulus as well that has been asked. So if you will do the brute force approach, so basically since you want to find n to the power r, so how much time you will take? You will take order of r time. Is that clear to everyone, guys? If we will run a normal loop now, so what we will do, we can say that maybe the product will be initially 1. Okay, and then what we can do is, we can also define mod as nothing but what? 10 to the power 9 plus 7. After that we can run a loop, I starts from 1, I is less equal to r, because r times we have to multiply the n. Okay, so what we can do is, we can say that product is equal to product into n, and then taking the modulo with the mod value, and ultimately we can return the answer. So basically manually we are doing what? Every time we are multiplying n. So in that case, what will be the time complexity, guys? And in the end we'll return the product. So in this case you can see that we will be running a loop, and because of that the time complexity would be order of r. Is the brute force clear to everybody, guys? Just let me know in the chat. Jashwant also, are you clear? And Rishit, is this brute force part clear to everybody, guys? Just let me know and then I will proceed further. In the brute force method, if I have to find n to the power r, so this means that multiplying n r number of times, so n into n into n. So basically what I can do is, I can run a loop from 1 till r, and then basically what we can do is, we can basically keep on multiplying the n value in the product and keep on taking the modulo with 10 to the power 9 plus 7, and that is how we can return the product. Okay, guys, clear with this? If yes, then please give me a +1 and hit the like button. Okay, so Rishit, I think, is clear with this part. Very good. Now other than this, what can be done, right? Suppose that if I have to find n to the power r, okay, so we have to find n to the power r. So let's say I am saying we have to find a to the power b here. So how can we find it in a more optimal manner? Is my video lagging? Let me just verify. Just a second. Or is it fine? Is my video lagging, guys? Let me know. I don't think so. Okay, I think it's fine now. Yeah, so basically suppose that you have to find a to the power b. So you know that if we want to do it in a faster manner, so instead of taking order of r time, what you can do is, now you can simply calculate this thing. You can calculate n to the power r using the fast exponentiation method. Okay, it is known as the fast exponentiation method, or you can say binary exponentiation also, right? So we can do what? We can use the binary exponentiation method in order to calculate. Video and audio is fine. Okay, thanks a lot, Rishit. So yeah, we can do what? We can use the fast exponentiation concept in order to calculate n to the power r. So now let us discuss what is fast exponentiation actually. So suppose that if I have to calculate a to the power 32, okay, suppose. So in this case, if I have to calculate a to the power 32, so what we can say is a to the power 32 is what? A to the power 32 is nothing but a to the power 16 into a to the power 16. Okay. Now a to the power 16 is what? It is nothing but a to the power 8 into a to the power 8. So basically, you can say that if you have to calculate a to the power b, so it is nothing but a to the power b by 2 into a to the power b by 2, right? So now if you have to calculate a to the power 8, so that is what? That is nothing but a to the power 4 into a to the power 4. Now if you just calculate one of the a to the power 4, so a to the power 4 is what? It is nothing but a to the power 2 into a to the power 2. Okay, and then a to the power 2 is what? A to the power 2 is nothing but a to the power 1 into a to the power 1. And then obviously a to the power 1 is a itself, you can understand, right? So basically what I'm trying to say here is, guys, if you will understand now, so we have reduced the steps a lot, because see, we are doing what? We are trying to say that, notice that this is very important. If you want to calculate a to the power 32 now, so in that case we can say that a to the power 32 is nothing but a to the power 16 into a to the power 16. So what I'm trying to say is, if suppose that somehow I am able to calculate a to the power 16, suppose in a temp variable I am able to calculate it and store it, then I can multiply it with itself again, and in this case I will save myself from calculating a to the power 16 two times. Are you getting my point? The thing is that what we can do is, if we have to calculate a to the power 32, that is nothing but a to the power 16 into a to the power 16. So for this, what we can do is just calculate a to the power 16 once and store it in a temp, and then multiply temp into temp. That is how you will get this particular result, a to the power 32. Is this part clear to everyone? Is this observation clear? Right? So does this make sense? If you have to calculate a to the power b, so it is nothing but a to the power b by 2 into a to the power b by 2. So just calculate this value, okay, in a temp and store it in a temp, and then multiply this temp into itself, right? Then just do temp into temp, and that is how you will be you will save yourself from calculating another a to the power b by 2. Is that clear? Study new things is clear. What about other people in the chat? Are you guys clear with this? If yes, please hit the like button and write clear or +1 in the chat, guys. Does this make sense to everybody? Rishit says yes. Okay, so basically you can see now, if we have to calculate a to the power 32, so that is nothing but a to the power 16 into a to the power 16. So just calculate a to the power 16 one time, and then what you can do is you can multiply this stored result into itself, such that you can get 32, right? A to the power 32. Similarly, if you have to calculate a to the power 16, so what you can do is just calculate a to the power 8 and store it in a temp variable, and then what will happen? Then multiply temp into temp and you will get it. Similarly, if you have to calculate a to the power 8, so just calculate a to the power 4 and multiply this value with itself, and you will get it. Similarly, so basically it will go from bottom to up, because from smaller answer the larger ones will keep on building. So suppose that you want to calculate a to the power 2, so just calculate a to the power 1 time and multiply the temp result with itself, and you'll get it. Then for a to the power 4, just when you will get a to the power 2 already, then just multiply a to the power 2 into a to the power 2, then you'll get the result. Is this part clear to everyone? So can I say, guys, one thing that we can very clearly say, that are we taking 32 steps? Please tell me, are we taking 32 steps here? No, we are not taking 32 steps. Actually, if you will see, so what are the number of steps that is being taken here? If you will see, so every time, see, here we are calculating, suppose what we are calculating, if you will see, so we are calculating a to the power, let's say b. Here we are calculating a to the power b by 2. Okay, then here we are calculating a to the power b by 4. Then here we are calculating a to the power b by 8. Then here we are calculating a to the power b by 16. Then here we are calculating a to the power b by 32. So basically you can see every time what happens, the value keeps on getting divided by 2. Okay, and basically when this happens, whenever the value gets divided by 2, then the time, like you have seen now in a binary search, what happens? Initially your search space is from 0 till n. Then after that, either you search in the left side or the right side only, so search space reduces by 2. Then in this search space also, either you search in the right side or the left side, so your search space again gets divided by 2, so it becomes n by 4. So it keeps on dividing half half half. So in binary search, the complexity is what? Logarithmic of n, if the initial search space is n. So basically here, since initial value was b, so since you keep on dividing by 2 every time, so the complexity will be log of b to the base 2. Is that clear to everybody, guys? Please let me know. Is this part clear? So if you want to calculate a to the power b, then the complexity, time complexity, will be nothing but order of log b to the base 2. Is that clear? Study is clear with this? What about other people? Others are also clear with this particular part? Yes or no? Okay, Rishit is also clear. Very good. So now, because if you will see now, ultimately what are we doing? If you will see, so we have a to the power b. Okay, then we are moving to a to the power b by 2. Then a to the power what? B by 4. Okay, up till we are moving. So up till where are we moving? Like up till some a to the power b by k we are moving. Correct. Like if you will see, up like we are moving up till where? Up till this guy reaches 1. Okay, up till we reach what you can say, yeah, up till we reach 1, up till the b reaches 1, till that time we are moving now. So up till we reach, let's say, this part. So you can see here basically what happens. This can be considered as a to the power b by 2 to the power 0. This will be a to the power a b by 2 to the power 1. This will be a b by 2 to the power 2, then so on and so forth. So this can be said as a b by 2 to the power k. Okay, so you can equate this equation. So b by 2k will be equal to 1. Then you can say, when you will cross multiply now, so what will happen? 2k is equal to b. So you take log base 2 on both the sides. Then what will happen? Log 2k will be equal to nothing but log 2b. So in this case, when you will solve it completely, so k will get here, and then it will be like k is equal to log b to the base 2, because log 2 will be 1 only. Okay, is that clear? So that is how the complexity becomes log b to the base 2, because you can see k value comes out to be log b to k value comes out to be log b to the base 2. Is that clear to everyone, guys, till now? If yes, then please hit the like button and give me a +1 for acknowledgement, because I can see a lot of you are there but still not commenting and telling me. So you can tell me, guys. Okay. Now another thing is, suppose that if I wanted to calculate a to the power 33. Okay. So in this case, what will happen? In this case, I can say that it will be nothing but what? A to the power 16 into a to the power 16 into another a I have to multiply. No, you can see here. Okay, everyone is clear. So you can see, if I have to calculate for odd power, whenever the power is odd, then in that case I will do what? You can say, if I have to calculate a to the power b, so this will be a to the power b by 2 into a to the power b by 2 into a, because I have to multiply another extra a that is there now. So once you calculate, like, see, if you store this in a temp, okay, then what you have to do is you have to do temp into temp, and then into a also you have to multiply if the power is odd. Is that clear to everyone? Is this part clear? So whenever the power is even, so whenever you are calculating a to the power b, so in that case, what you can say is, you can say that temp will be equal to nothing but you will calculate power of a comma b by 2. Okay, and then if it is even, if the b value is even, right? So in this case, what will we do? If it is even, then we can simply return what? We can simply return temp into temp. Okay, because we need to return only a to the power b by 2 into a to the power b by 2. Otherwise, if that is not so, then in that case, as I said, if you are calculating a to the power 33, so if the b value is odd, then it will be nothing but a to the power b by 2 into a to the power b by 2 into a. So that will be nothing but you have to return what? So a to the power b by 2 is calculated in temp, so you have to return temp into temp, then into a. So that is what we have to do, and obviously we need to keep the we need to take the mods as well. So is this part clear to everyone, guys, or still someone is not clear? Please tell me, and also hit the like button if you are clear till this point. So basically, in this problem, what you have to do, we have to calculate this thing. We have to calculate n to the power r. So basically, you can say that the time complexity taken will be order of log of r to the base what? To the base 2. Is that clear to everyone? Okay, guys, is this part clear? So basically, if you are doing something again and again, no, so this is nothing but recursion. So what will be the base case? The base case is that if the b value becomes 0. Okay, so suppose that if your if the r value becomes 0, if you keep on doing like a to the power 0 is what? 1. So in that case, you will simply return 1. Okay, otherwise what you will do is you will calculate the smaller result. So you will do what? Long temp is equal to what? Temp is equal to nothing but this thing. You will calculate power of 10 comma r by 2. Okay, and then after this part is done, then what we will do is we can say that just a second, let me declare the mod also. So we can say long mod is equal to 1e9 plus 7. Okay, this is what we can try. And as I said, if it happens that the r value is even, so if suppose that r mod 2 is equal to 0, if the power is even, then you can directly return what? You can directly return temp into temp, then taking the modulo with the mod. Okay, otherwise what we will do is if it is even, then we'll just multiply temp into temp and take the modulus. Otherwise, if it is odd, then what we need to do is we need to do temp into temp. Okay, and we need to take the modulus. But sorry, let me take this outside. So yeah, basically we need to take the modulus, but after this we also need to multiply this resultant with the n value again, because this is the thing. And then we need to take the modulus again. So if it is odd, then we need to multiply the number once again. So that is what we need to do. Is this part clear to everyone, guys? Can you do a dry run on example? Yeah, I can try to do the dry run, Rishit, don't worry. Let me just try and fix this first of all. Okay, is it clear till now, guys, to all of you? Let's see if it is running properly or not. I hope it does. Yeah, running on the samples. Let's try and submit this code also and see what happens. Yeah, it gets accepted. So is this problem clear to everyone till now, guys? Fast exponentiation or binary exponentiation? Basically, see, you are doing the same thing again and again. You are calculating the power only again and again. So that is why you can call the same function. So that is why this will be nothing but recursive approach. Why we are taking modulus two times? Here we are taking modulus two times because like see, if you are multiplying temp into temp, right? So if you are multiplying these two elements, then you take the modulus. So basically you will see now, here you are doing what? Here you are doing temp into n. Okay, so that is why what you need to do is now you need to first of all when you are multiplying this t, so if you just multiply all these three variables and then you take the temp, so it might happen that it might overflow. So that is why what you need to do is first of all, when you multiply these two, then when you multiply temp and temp, so then you need to take the modulus so that they are under control, and then after that whatever you get, that you need to multiply with n. So then take the modulus, so that it does not overflow. Otherwise, you will, if you will do temp into n, and then you will take the modulus now, so in that case it might have overflown before taking the mod only. So just to avoid the overflow, we need to take the temp multiple times. Is this part clear to everyone, guys? Just let me know. Is it clear, guys, till now? Right? Okay, you have a doubt. Why we take mod any number? Why can mod any number of times? Why can mod any number of times? Can you please clarify again what you want to ask? Like, why do we take mod? We take mod basically because when you will take such a high power, na, so then actually suppose that if you are taking 12 to the power 21 or something else, you are taking 21 to the power 12 or some higher values, then in that case it might the power that you are calculating, it will exceed the long limit also. So in that case actually you will never be able to store, because long can actually store how many? I think 18 or 19 digits it can store. So you will never be getting the exact answer. If the value is very high, then long even will not be able to store it if you are calculating a very high power. Okay, if the base is also high and the power is also high, so if a is also high, b is also high, then it will be very high value. So it will not get stored. That is why we do what? We take the modulus so that we can get an approximate idea whether our answer is correct or not. Can we take mod any number of times? uh yes, you can take it here, but I am taking it because when you multiply temp and temp, na, so we need to take the mod here, and then after that when you multiply n again, then also we need to take the mod. Okay, let me just first of all generate the code link, and then I will tell you a bit more about this question. And obviously you can see this question was asked in Make My Trip and Walmart. So Walmart is a pretty good company, and it pays a high package, obviously. Just give me 1 second and let's generate the link, and then we'll talk about the question further. Okay, so yeah, this is the solution link. Okay, now coming back to this problem and what Rishit was saying. So basically, guys, what I want to tell you is, how do you solve, like, how, what is recursion? Okay, so can I say that if I will ask you to calculate 5 factorial, okay, so you will tell me that 5 factorial is nothing but what? It is nothing but 5 into 4 factorial. Correct? That is what you will tell me in the normal. That's yes, any number of times. Okay, mark. So yeah, if suppose that if we are talking about the factorial concept, okay, so if I ask you to calculate 5 factorial, so you can tell me that 5 factorial is nothing but what? 5 into 4 factorial. Correct? So basically you can understand, when we are trying to calculate a to the power b, okay, then what concept we use, we are saying that we need to calculate a to the power b by 2 into a to the power b by 2. So basically, from a, like, if we want to if we want to calculate a higher value, so we are saying that we need a smaller result first of all, right? This is the smaller result, so we need the smaller result first of all, and then we can multiply this smaller result into itself, and then we can get the answer. Are you getting? So similarly here also in factorial, if you will see, so if you remember, if we are writing a recursive code, so suppose that fact is a function which fact of n is a function which can give me the factorial. So if I have a function, let's say int fact, okay, and in that I am having int n here, so what can I say? I can say that if suppose that the n value becomes, let's say, equal to 1, then I can simply return 1, because 1 factorial is 1 itself. Otherwise what I will do is, now, otherwise guys, we need to store the smaller result. Okay, if we want to calculate n factorial, so we can say that first of all, for ourselves, we need to get what? N minus 1 factorial. Okay, and then what we need to do is, then we will say that we will now return n into the smaller result. Okay, smaller result. So n into n factorial basically will return. Is that clear to everyone, guys? Is this part clear? What is the use of recursion? So whenever we want to whenever we can relate the things that we want to store the smaller result. Okay, so like, we need the smaller result. So whenever fact of n is a function which can calculate the factorial of any number, so if you want 5 factorial, so we can say that 5 factorial is nothing but 5 into 4 factorial. So if you want n factorial, okay, so you can say what? You can say that n factorial is nothing but what? N into n minus 1 factorial. So what we can do here is, if we can write a base case that is, if n value is 1, then you can return 1. Okay, otherwise you first of all calculate the n minus 1 factorial, that is the smaller factorial, and then multiply the n with the smaller result and return it. Is that clear? So this is what we do in the normal recursion. Now here also we need the same thing. Why we need the same thing here? Because if you will see, we are saying that if we want to calculate what? Suppose that we want to calculate a to the power b. So in this case, we can say that we need a to the power b by 2 first, and then we need to multiply a to the power b by 2. Correct? So you can understand that if we want this result, then we want the smaller result to be calculated. Okay, so if we have a power function, so suppose that we have a int power function that we were having, or long power function. So let me write this. Let's say we have a long power function here. Okay, and it had what? Int let's say a comma int b with itself. So if you want to calculate a to the power b, na guys, so the base case is that if the b value becomes equal to 0, then in that case obviously anything to the power 0 is just 1. Okay, otherwise what we will do is we'll calculate the smaller power. Okay, so that is what I was saying. In the temp, you can say temp is nothing but calculating the smaller power. Okay, temp is calculating what? A to the power b by 2. So you can say smaller power. Okay, smaller power. So basically you will like, just you were doing in the factorial also, now you're calculating n minus 1 factorial, because n factorial was nothing but n into n minus 1 factorial. So you were calculating n minus 1 factorial. So basically a to the power b is what? A to the power b by 2 into a to the power b by 2. So in the temp, we calculate this value, okay, in the as a smaller result, and then we multiply with itself. So that is what we are doing, and based on the even or odd value, we multiply again. So basically we can say that temp will be what? We'll call this function power function for a comma b by 2. So we'll calculate the smaller power, and as we know that if it happens that the b modulo with 2, if it is 0, okay, so if the b is even, so in that case we don't need to multiply again. So if this is 0, then what we can do is we can simply return this thing. We can simply return what, guys? Temp into temp, right? Modulo with the mod, okay, with the mod value. Otherwise, if it is odd, so as I said, if you want to calculate a to the power 32, so that will be nothing but a to the power 16 into a to the power 16, okay, where in the temp this is already calculated. In the temp you will get this. So then you can multiply it with itself again, and you'll get this answer. Otherwise, if you want to calculate a to the power 33, so that will be a to the power 16 into a to the power 16 into another a. So that will be temp, right? if this is temp, so you will do what else? You will do return temp, okay, into temp, and when you multiply these two, then you need to take the modulus so that this does not overflow. And after that, with this value, if you're multiplying another this thing a, then after that you again need to take the modulus so that overall multiplication does not overflow. Is that clear to everyone, guys? How the smaller result is important at the end? Yeah, I can try to explain it also. Is this much part clear to everybody, guys? Just let me know, and then I will proceed further, guys. Is this part clear? Like, just you do in the, like, the same thing you do in the factorial now. For calculating the factorial, the same approach that you use, similar kind of approach we are using here as well. So is this understandable or not, guys? Please let me know. That if you want to calculate the like a to the power b, so in that case, first of all, you bring your dependency to a to the power b by 2, and based on the value of b, whether it is even or odd, you will decide whether to multiply another guy or not. Okay, Balaji is also saying yes, sir, clear, very good. Now coming back to this scenario, suppose that if I want to do what, if I want to calculate this particular thing, let's say if I want to calculate something like, let's say I will take a smaller example. Let's say if I want to calculate, guys, what I want to calculate is, let's say if I want to calculate something like 2 to the power let's say what, 10. Okay, if I want to calculate this particular thing, then what will happen? I'll say that let's calculate 2 to the power 5 first of all, and then whatever it the result will be, we'll multiply with itself, right? So now 2 to the power 5 is what? It is nothing but you can say it will be nothing but what? It will be nothing but, you can say, as 2 to the power 2 into 2 to the power 2. Okay, and 2 to the power 2 is what? 2 to the power 2 is nothing but 2 to the power 1 into 2 to the power 1. And 2 to the power 1 is what? 2 to the power 1 is what? 2 to the power 0. Okay, into 2 to the power 0, because 2 to the power b is what? 2 to the power b by 2 into 2 to the power b by 2 into this thing. If the value is odd, then you multiply again. So just a second, here also you need to multiply again, and here you will multiply it with 2. Is that clear, guys? So can you see what will happen? You will keep on calling. So it keeps on calling for the lower cases, and this is when you hit the base case. So in the temp, when the temp is here now, just at this particular point, so this is the base case when you hit the base case, right? So then in the temp, this is calculated. So temp value is nothing but 1 here. So you will do what? You will do 1 into 1 and then multiply with 2 also. Why? Because the value, the power was odd, so you need to multiply an extra 2 here. And you can see, because this will be 1 into 1 into 2. Okay, so that will be overall 2. So this guy, in this guy, you can say that this is storing 2. Okay, this is storing nothing but 2. So in this temp, you are storing 2. Now temp into temp will be what? 2 into 2. So this will come out to be 4. So for this particular value, 2 to the power 2, you will get the value as 4. So this will return 4 here. So in this part and in this part, you can see that this will be 4. So in the temp, you have stored 4, and here also you have stored 4 here. Then you do what? 4 into 4 into 2. So this will become what? This will become nothing but, I think, 16 into 2, 32, right? So 2 to the power 5 will become 32. So when this becomes 32, so then what is going to happen? So since this becomes 32, so in the temp, what will happen? 32 is stored, and then you multiply temp into temp. So 32 into 32 will be nothing but some particular value that will be returned. So this will be, this is how 2 to the power 10 will be actually returned, because 32 into 32 will be, let me just check, 1024. So yeah, then you will say that this result is going to be 1024. So that is why this 2 to the power 10 will return 1024 overall. Is that clear to everybody, guys? Now is the dry run much more clear or not? So basically, you will keep on calling. You will keep on breaking the problem into the smaller case, and whenever you hit the base case, so this will be calculated, and one by one, each step you will be going up, because these results will be calculated, and ultimately you will return 1024. Sure, Rishit is clear. What about study new things? Are you clear with this as well? And what about other guys also? Guys, does this make sense or not? Rishit is clear with this. Balaji is also clear. Study new things. Are you clear with this? The dry run. Rishit, you are clear with the dry run, or you need some more support here? Let me know, guys. Okay. So yeah, this is how you can solve this particular problem. And yeah, this problem was asked in Walmart. I have solved this problem a lot of times, and this concept is nothing but fast exponentiation. So in case if you want to read it, so I'll just provide you the this thing, fast exponentiation. I'll provide you with the GFG article. Okay, you can do it in iterative as well as recursive manner. Dry run is clear. All right, great, Rishit. So yeah, this was the dry run. And in case, let's see what is the problem of the day for today. Okay, although I'll not be solving it today only. So if I'll just search GFG POD, and then, so yeah, this problem is unique number of occurrences. So in this, the task is to check whether the frequency of the element is unique or not. In other words, there are no two distinct elements. So I think you are getting this, how to solve this. This is a easy problem, and it has been asked in PayPal, Bloomberg, Adobe, Google. So try this problem out, and tomorrow I'll be discussing this particular problem with all of you. So if you're clear till the very end, guys, okay, if you're clear with the explanation and everything, fast explanation, and why the complexity is order of log n, if you are, suppose if you are calculating a to the power b, so the complexity will be order of log b to the base 2. So why the complexity is logarithmic to the base 2, I have also cleared this thing. So if you're clear in the very end with everything, so please give me a +1, and I've shared the article as well, and also the solution was shared. So if you're clear with everything, so please write clear, give me a +1, and hit the like button if you haven't already, and then I'll end this session. Okay, guys? So just let me know. Everything is clear? And I have given the factorial example also, because you like when you are calculating n factorial, so it is nothing but n into n minus 1 factorial. So you break your dependency into the smaller ones. So that is why a recursive approach. Okay, thanks a lot, Rishit. Thanks a lot, Balaji, and thanks a lot, Study New Things as well. So thanks a lot, everyone, for joining for today's session. I'll see you tomorrow with another problem of the day. Till then, keep coding and keep solving the problem of the day in this month of July, because every problem that is being solved, every problem of the day that is given to you, they are asked in some companies or the other. So the problems are prepared, keeping in mind that the placement season is coming. Thanks a lot, guys, and take care, everyone.